Hello students, welcome to AKN Sprint Education. Myself Naveen, and today's session regarding electric current numericals. Most of the times they will ask numericals from this chapter. Okay, so first of all we have the three concepts. Based on that three concepts they'll ask most of the numericals. The first one is electric current. Electric current I equal to Q by T, whereas Q is charge, the SI unit of charge is coulombs, T is time, the SI unit of time is seconds, I is nothing but electric current and the SI unit of electric current is amperes. And the second formula is potential difference V equal to W by Q. Potential difference V equal to W by Q. V is nothing but potential difference. The SI unit of potential difference is volt and W is nothing but work done. The SI unit of work is joules and Q is nothing but charge. SI unit of charge is coulombs. Also we have Ohm's law, that is V equal to IR. V is potential difference, I is electric current and R is resistance. Okay. So also we have, when resistors are connected in series, effective resistance R is equal to R1 plus R2 plus R3. When the resistors are connected in parallel, effective resistance 1 by R equal to 1 by R1 plus 1 by R2. Right? Also we have power, electric power P equal to V into I. So based on power also they will ask the formulas. These are the formulas you have to remember when we are doing numericals from this chapter. Okay. If you read the question carefully, everything we can do it easily. When a 12-volt battery is connected across an unknown resistors, there is a current of 2.5 milliamperes. What is given? Potential difference is given how much? 12 volts. Is connected across an unknown resistor. There is a current. Current is how much? I equal to 2.5 milliamperes. Actually, the units are here milliamperes. We need to convert into amperes. Nothing but 2.5 divided by 1000 amperes. So as I converted milliamperes into amperes. So we have actually three zeros. It will become 0.000. I mean, here nothing means 1, 2, 3, 4. 0.0025 amperes. Right? 0.0025 amperes. Actually, we are shifting how many pairs? 1, 2, 3. 1, 2, 3. 1, 2, 3. 0.025. amperes. We got the current as well as. Any doubt, students? Because we have only three zeros. 1, 2, 3. I mean 0.25 amperes. Right? Current also we got. Now what they are asking to find? Find the value of resistance. R value we have to find. Given ఏమి ఇచ్చాడు, మనకి ఏం ఫైండ్ చేయాలి అది మనం చూసుకున్నట్లయితే ఈజీగా మనం ఆన్సర్ చేయగలుగుతాం. So according to Ohm's law, what is Ohm's law here? V equal to IR. But actually what we want to find? We need to find R value. So the formula for R is V by I. The formula for R is V by I. So what is V? As V is 12 volts divided by I is 0.0025. Right? Students, here after point 1, 2, 3, 4 digits are there. So I need to multiply into 10,000 into 10,000. It will become 1,20,000 divided by 25. Right? Now 25 4 ja 100, 20, 25 8 ja. So resistance is equal to how much? 4,800. And what is the SI unit of resistance? SI unit of resistance is ohms. OHM, ohms. Is it clear, children? How they are asking to find the value of resistance, okay, which is the one of the most important topic based on Ohm's law. Is it clear, children? Now coming to second problem, how do the resistors 6 ohms, 10 ohms to be connected in a circuit to get minimum resistance? To get minimum resistance, find the resultant resistance of the circuit. So children, one of the important note is here, if you want to get minimum resistance, we need to connect the resistors always in parallel. Is it clear? To get maximum resistance, we need to connect the resistors are in series. These 2 points you need to remember. So the word parallel is important here. To get minimum resistance, 6 ohms and 10 ohms to be connected in parallel. Right? Now also they are asking to find the resultant resistance of the circuit. When we connect the resistors are in parallel, what is the effective resistance formula? As effective resistance, 1 by R is equal to 1 by R1 plus 1 by R2. So 1 by R is equal to 1 by, this is our R1 6 ohms and this is our R2 10 ohms. So 1 by R equal to, as the LCM of 6 and 10, what is the LCM of 6 and 10? 2 3 is 6, 2 5 is 5 3 is 15, 15 2 is 30. 6 5 is 30 into 5 into 5. 10 3 is 30 into 3 into 3. 1 5 is 5. 1 3 is 3. 1 by 6, 1 by R equal to 5 plus 3, 8. 8 by 30. So effective resistance R by 1 equal to 30 divided by 8. Let us divide. 8 3 is 24, 6. 8 7 is 56, 4, 0, 8 5 is 40. Right? So effective resistance R is equal to 3.75 ohms. Clear, children? When you get minimum resistance, we need to connect the resistors are in parallel. Effective resistance formula is 1 by R equal to 1 by R1 plus 1 by R2. Then we need to substitute the values so that we will get the resultant resistance. Now coming to third one. So which is the most important question? Draw the experimental setup to verify that V by I is a constant for a conductor. We need to draw the circuit diagram to verify that V by I is a constant for a conductor. So this is a battery connected to ammeter. As the current is flowing, and this is a conductor, and this is voltmeter. This is our electric circuit diagram, and we forgot to put the key here. This is our battery and this is our conductor. So B stands for battery, A is ammeter, K is key, C is conductor, V is voltmeter. So this is the circuit diagram to set up, verify that V by I is a constant. As battery, B stands for battery, A is ammeter which is used to measure electric current, K is switch on, switch off. We have kept here conductor and how much current is maintained between ends of the conductor, that can be measured by using voltmeter. Voltmeter, which is used to measure the potential difference between the ends of the conductor. As the current is flowing in this manner, right? This is the circuit diagram to set up V by I is a constant for a given conductor. Now coming to question number 4, an electric motor takes 2 amperes from 100 volt line. Determine the power of the motor. So we know the formula, electric power P equal to V into I. Electric power P equal to V into I. And what is given? Given current I is 2 amperes and potential difference is 100 volts. Simply P equal to, as V is 100 volts and I is 2 amperes, 100 into 2, 200. So what is the electric power P equal to? 200, and the SI unit of power is watts. Okay, and the commercial unit is kilowatts. Is it clear? How it is a direct question. Sometimes they will ask for 2 mark question, that too directly. If you know the formula of electric power P is equal to what? V into I. So as V is given 200 volts and I is 2 amperes. So P equal to V into I, 100 into 2, that is equal to 200 watts. Now if you see fifth one, draw the electric circuit with the help of battery, voltmeter, ammeter, resistance and conducting wires. Okay, here they are asking to draw the electric circuit diagram, basic electric circuit diagram. In third question we did setup of V by I is a constant for an electric conductor. That is different and this is different. Simple electric circuit diagram we need to draw with the help of battery, right? So this is the battery. And this is ammeter. They are asking with the help of battery, voltmeter, and this is our resistance R, and we are maintaining potential difference V in between ends of the resistors, battery, and then voltmeter, and then ammeter, and then resistance, and these are conducting wires. As current is flowing in this manner, these are conducting wires. Clear? We have used all the materials here. First one is battery, and second one is voltmeter, and third one is ammeter, fourth one is resistance, and these are conducting wires. This is the basic simple electric circuit diagram. Okay, most of the times they are asking this question, draw the simple electric circuit diagram. Okay, easily you can gain the marks. Now coming to difference between ohmic conductors and non-ohmic conductors. First of all, what do you mean by ohmic conductors? The conductors which obey Ohm's law are called ohmic conductors. The conductors which obey Ohm's law are called ohmic conductors. So what about non-ohmic conductors? The conductors which does not obey. The conductors which does not obey Ohm's law are called non-ohmic conductors, right? So that is the difference between ohmic conductor and non-ohmic conductors. So ohmic conductors are generally they are electric conductors, whereas non-ohmic conductors are semiconductors, right? So these are electric conductors and whereas these are semiconductors. And V by I graph for ohmic conductors, V by I graph is a straight line. V by I graph is a straight line. I mean, so this is our V and I, you will get a straight line. Whereas V by I graph for non-ohmic conductors is a curved line. You will get a curved line here. So that is the difference between ohmic conductors and non-ohmic conductors, which is the most important 2-mark question. Simply, the conductors which obey Ohm's law are called ohmic conductors. These are electric conductors, and V by I graph is a straight line. Now coming to non-ohmic conductors, the conductors which does not obey Ohm's law are called non-ohmic conductors. These are semiconductors, and the V by I graph for non-ohmic conductors is a curved line. Is it clear, children? Now what is the value of 1 kilowatt hour in joules? Right? As 1 kilowatt hours, we know that 1 kilowatt is nothing but 1000 watts into 1 hour, right? Is it clear? 1 kilowatt is nothing but 1000 watts into 1 hour. Again 1 hour is nothing but, so this is 1000 watts. The 1 watt is nothing but 1 joule per 1 second. Joule per second into 60 minutes, and 1 minute is equal to 60 seconds. So 1000 into 6 into 6, 36. So here we have how many zeros? 1, 2, 3, 4, 5. I can write as 36 into 10 to the power of 5 joules per seconds. Joules per seconds, right? And I can cancel seconds and seconds, because this is also seconds. If I write joule by second into this second, this 1000 joules per second into second, second cancel, 36 into 10 to the power of 5 joules. So children, 1 kilowatt hour in joules is nothing but 36 into 10 to the power of 5. 36 into 10 to the power of 5. This is also one of the important 2-mark question. Now coming to another question, what happens if the household electrical appliances are connected in series? What happens if household electrical appliances are connected in series? If one connection fails, suppose if one connection fails, the whole appliances stop working. Suppose as we are connected, our electrical appliances actually in parallel, so we should not connect in series, because if one appliance stops working, the whole circuit stops working. Then it will be difficult for us to do our normal things. Okay children, what happens if the household electrical appliances are connected in series? The whole appliances stop working because of incomplete circuit. If one appliances fail, the whole system fails because of incomplete circuits. That is our answer for the given question. Okay children, I hope you understood today's session. I discussed all the important sums and questions. So kindly go through this session and try to achieve good marks. Thank you children.